We will now proceed with the next topic for this chapter, which is call by reference parameters. From the previous chapter, we've already discussed about call by value parameters. So talking about those kind of parameters, those are the kinds which we pass values directly to an argument. So in return, whatever value that we provided as arguments will directly replace and serve as the value of the parameters for that particular function that was called. On the other hand, we have another kind of how we pass parameters, which is through by reference. So today we will know the difference between the two as well as how to use call by reference parameters. Call by value is not adequate when we need a subtask to obtain input values. So, call by value means that the formal parameters received the value of the arguments. So that's the ones that we see in the previous chapter. And to obtain input values, we need to change the variables that are arguments to the function. So recall that we have changed the values of formal parameters in a function body, but we have not changed the arguments found in the function call. So which means the value that we provided as arguments will only change the value of the parameters in that particular function only. On the other hand, call by reference parameters allow us to change the variable used in the function call. Thus, arguments for call by reference parameters must be variables and not numbers. So how does this work? So as we go, we will see in a couple of examples. So how do we make a call by reference parameter? So let's take a look at this example. As we can see here, this looks like an ordinary function definition. However, if we will look closer, there's a difference that we can see. So as you can see here in the formal parameter section, we can see that there's an ampersand symbol that comes after the data type for our formal parameter. So the ampersand symbol identifies the variable as a call by reference parameter. So as you can see there, that's how we declare a call by reference parameter. Of course, we must use that both in the declaration and definition of our function. So let's take a look at an example. Here. So here's an example which demonstrates call by reference parameters. So as you can see here, we have the following functions which has call by reference parameters. Okay, for the function declaration of the get numbers and swap values, take note of the ampersand symbol, which signifies that these formal parameters are declared as call by reference parameters. On the other hand, we have here another function which has regular parameters, which in this case are considered as call by value parameters. And this is how the following functions are called in our main function. And let's also take a look at the function definition of get numbers and swap values. So if we will take a look at this, I think what the program does is quite obvious. So what happens is, of course, we're going to input two numbers and the value of those will be swapped, okay, just like this one. Then we will call another function, the show results function, which will now display the value of our variables after the swapping process. So let's try to run this. Okay, so for example, I'm going to enter two integers. I'm going to enter 35 and 6. Okay, so what will happen is, of course, they will be swapped. Okay, so if we're going to look at this example, actually it's really simple, but the point is what really happened inside our program. So let's take a look. So again, as you can see here, okay, so for our first function, this is where the arguments will be passed, okay, in this function called routine. Okay. Hence, whatever value that we provide in these arguments will be placed in these formal parameters. However, what happened here actually is that we are not only placing the values of our argument, okay, the argument that we provided here, but also, okay, we're also trying to put a reference on the actual memory of address of these formal parameters. So which means that what we have right now is actually a copy of the actual memory location of these formal parameters. So which means since we now have the reference, whatever changes that we put into these variables, it will be reflected all throughout our program. So for example, after the getNumbers function was called, we're going to call the swapValues function. So take note that for the swapValues function, okay, we have the same set of formal parameters which are of type call by reference. Now let's take a look at this one, at this function call. Take note that both getNumbers and swapValues refer to the same variables, first num and second num. So which means since both of them were declared and defined with call by reference parameters, it means that they both have the reference to the memory address of these variables. So which means whatever is done with these variables during the swapValues function call will be reflected on the actual variables that we declared in the main function, since it is a call by reference parameter. Hence, that explains why the moment that we call show results, okay, as shown here, it is also referring to the same parameters, which are passed by reference parameters. Okay, so therefore, whatever change that we did here in the swapValues function will also be reflected here, since they are a call by reference parameters. So that explains what happens in this example. Again, let's run it. Okay, I'm going to provide, let's say, 89 and 65. So that's it. Okay, next. So what are the details about call by reference? So call by reference works almost as if the argument variable is substituted for the formal parameter, not the argument's value. So what we are referring there actually is the memory address and not the actual value of the parameter. Okay, so in reality, the memory location of the argument variable is given to the formal parameter. So to see how it works, let's take a look at this. Okay. So this is what I mentioned a while ago. Okay. So assume that we have the variables first num and second num, which have been assigned the following memory address by the compiler. Okay? So this is what happens every time we declare a variable. Okay? So it is actually assigned with a memory address. So the same applies for a formal parameter. Okay? Next, in our previous example, remember that we have the following function call for get numbers, in which we provide the arguments for first num and second num. So the function is told to use the memory location of the variable first num in place of the formal parameter input 1. Okay, so if we will look back, this is what happened in our previous example. So the effect is the same if the function definition were written to the following, such as this one. Okay? Since we declare it as a call by reference parameter, so what we are doing here actually is we are assigning here the memory location for the variable first num, same also for the variable second num, which is in this case declared as a call by reference parameter. So since the variables in locations of this memory address, okay, are first num and second num, so the effect is thus the same if the function definition were written this way. So which means whatever that we do, okay, with these variables which are used as arguments, since they are marked as call by reference parameters by the following functions, so any change will be reflected all throughout our program in which these variables are visible. Next. Okay, another one. So therefore, if we execute the function, the effect is same as the following. So in this case, the cin statement is executed. The values of the variables first num and second num are set to the values that we provide from the keyboard. But of course, remember that we now have the reference to the memory location of this variable. So therefore, whatever change that we did in the other functions, such as swap values, was also reflected all throughout the program. So that was seen after we called the last function, which is show values, which also showed the the function which is show results, which shows that the swapping process indeed took effect and showed our two variables in reverse order. Next. So deep inside our program, this is actually how it looks like. Now, if we are going to compare call by reference and call by value. So again, I've already mentioned that when we talk about call by reference, we are actually referring to the actual memory location of our variable as compared to call by value, which of course contains the actual value of our variable. So this is how it would look like. Okay, so this one, we are going to declare it as a call by reference parameter. So this is what it is going to contain given the following variable names. Okay, so if it was declared as a call by reference parameter, of course it's going to contain the memory location. On the other hand, if it was declared as a call by value parameter, of course it will only contain the value that is provided in each function call, and of course it depends whatever the value of the argument is. Okay, so that was our previous example. Okay, let's proceed. And of course it's also possible for us to mix our parameter list. So that's where we have mixed parameter lists. So in this case, call by value and call by reference parameters can be mixed in the same function. So, for example, we have the following. Okay, so as you can see here, we have three formal parameters, and of course, two of them are actually declared as call by reference parameters, while the other one was declared as a call by value parameter. Okay, so how do we choose parameter types? Of course, it's also important to know how we choose parameter types. So how do you decide whether a call by reference or call by value parameter is needed? First, we have to know if the function need to change the value of the variable used as an argument. Okay, so otherwise, if we're going to use the value provided as an argument local to the function only, then uh, we can just use call by value parameters. Otherwise, if we have to reflect every change all throughout the program, then that's the time that you need to use a call by reference parameter. Here's another example. Okay, so for this example, this is another example which shows the difference between a call by value parameter and a call by reference parameter. So we have the following. Okay, so we have the following variable, okay, declared in our main function, so which means it should be visible all throughout our main program. Okay, and we have the following function. Okay, so take note that its first parameter is a call by value parameter, and the second one is, of course, a call by reference parameter. And this is what happens inside this function. Okay, so for the first parameter, we are going to provide a new value 111, then output that. And on this part, we are also providing a new value for parameter 2 as well as output that. Okay, now let's take a look at the main function. So what's happening here is that right after declaring these two variables, we initialize them with their respective values, 1 and 2. And as you can see here, we called our function. So take note that we provided n1 and n2 as our arguments. So what will happen is, of course, whatever value that we assigned here for our arguments is supposedly will be passed into our parameters. However, the difference is that, of course, the first one is a call by value parameter, while the other one is a call by reference parameter. So what happens here is that, of course, we tried to override the content of our variable and output that, and on the other hand, we do the same with the second parameter. So let's run this example. Okay, so as you can see here, we did the following. Okay, so if we will recall, we initialized both variables with the following value: n1 equals 1, n2 equals 2. And after calling the doStuff function, okay, so we reassigned it with a new value, 111 and 222. However, take note that after the execution of the doStuff function, take note that n1 retained its value. Okay, on the other hand, n2 was overridden. Okay, so actually the reason is quite obvious. It's because that the other one was declared as a call by value, while the other one is declared as call by reference. So in this case, okay, the call by value parameter was able to retain its value because, of course, its visibility is only within this function, and whatever was done during the function call has no effect on this variable because such effect is only visible within this function call as compared with the second parameter. Since it is a call by reference, so we still have reference to the memory location of n2, which enabled us to overwrite its original value and change it with 222. Now, there will be times that we face errors in which we inadvertently created local variables without, of course, without the intention of declaring a local variable. But since we are talking about call by value parameters and call by reference parameters, it's quite common to fall for these mistakes. Okay, so what we mean here is that if a function is to change the value of a variable, the corresponding formal parameter must be a call by reference parameter with an ampersand attached. So, as we've mentioned a while ago. Okay? And on the other hand, if we forget to put the ampersand, it's going to turn that parameter into a call by value parameters. As you can see, that's not actually a syntax error, which will be automatically called out by your compiler. So therefore, it will still be accepted, compiled, and run. So therefore, if you're not able to detect that, so that could be quite a problem for your program. Okay. So if that happens, so of course, the value of the variable will not be changed, and the formal parameter is instead a local variable that has no effect outside the function. So that's quite a hard error to find, and as I've mentioned, that's not going to be marked as a syntax error. It will be accepted, it will be compiled, and it will be run. However, it is expected that your program is going to produce wrong output. So let's take a look at an example. So here. So this is actually the same program that we have here. Okay, where we swap the values of our two variables. Okay, only that this time what happened is that we forgot to mark swap values as call by reference parameters. Okay, so for example here, okay, so take note. Okay, assuming that we forget to mark them as call by reference parameter. So of course that would still be accepted by our compiler. Our program shall compile and run, but of course it will produce the wrong output. Okay, so for example, let's run this example. Okay. Okay, I'm going to enter 80 and 65. Okay, so as you can see there, the numbers were not swapped. It's because we forgot to mark them as call by reference variables. So to visualize what happened here, okay, so let me change this function. Okay. So what I want to do here is that I would like to demonstrate what is actually happening inside this function. So I would like to output the current value of variable 1 and variable 2 after this function call. Okay. So again, I'm going to run this. So take note of this output, okay, for the swap values function call. Okay, I'm going to provide 98 and 65. Okay, so as you can see there, when we call the swap values function call, of course, the values were swapped since this is what this particular block of code does. No? So the swapping actually occurred here. Okay, but the problem is, okay, it is only visible within this function. So therefore, whatever swapping that we made here, it only took effect within this function. But the moment that we go out of this function, okay, the order of our variables are still the same, 98 and 65. Okay, it's because, okay, we only have the reference to the actual value inside this function. However, we don't have the reference to the memory address of the following arguments. So therefore, after swap values was called, okay, we still have the same value for first num and second num. So therefore, no swapping occurred. Okay, okay, let's continue. So at this point, you now know how to write a void function definition for a function called and has two different parameters, both of which are variables of type int and sets the values to both variables to 0. And of course, we now know how to write a function that returns a value and has a call by reference parameter. And finally, we now know how to write a function with both call by value and call by reference parameters.